Welcome to a session about uniform cost search algorithm. First, let us see about what is uniform cost search algorithm. Basically, in the artificial intelligence searching techniques, we have two types, two categories. One is the informed search and another one is the uninformed search. This uniform cost search is under uninformed search. So uniform cost search, it is a one type of search algorithm that finds the least cost path. So this is very important. Least cost path. This least cost path also, we are considering the cumulative cost from the start node to goal node. From a starting node to a goal node by always expanding the node with the lowest cumulative path cost. So path cost only don't consider from one node to another node. From the start node to goal node, what is the cumulative path cost? That should be the minimum value will be considered for expanding the node position and finding the best solution. So this is one type of uninformed search. So it is used for traversing a weighted tree as well as graph. It comes into a play when different cost is available for each edge. So consider any graph or tree. So each edge having different cost. This algorithm comes into the picture. The goal, what is the motivation, what is the use of UCS is to find a path to the goal node which has the lowest cumulative cost. Okay, though this word is very important. Cumulative cost we should consider. It expands nodes according to their path cost from the root node. So what type of data structure, different type of data structures available? Stack, queue. In the queue itself, we have another type is priority queue. Here we are using priority queue data structure for solving the problem with the help of uniform cost search algorithm. So UCS, so what is the procedure should be followed for solving the problem with the help of uniform cost search method? First initial stage, insert a root node into the priority queue. First we can consider one priority queue. Insert the root node into the priority queue. Remove the element with the highest priority. So next remove the element with the highest priority. If the removed node is goal node, so then print total cost and stop the algorithm. Or else enqueue all the children of the current node to the priority queue with their cumulative cost from the root as priority and current node the visited list. So this is the procedure or algorithm should be followed to solve the problem based upon the uniform cost search method. First insert the root node, check and remove the root node from the priority queue and keep it in the visited list, and we can check whether that is the goal node or not. If it is not a goal node, expand that first initial root node, and then based upon the cumulative cost value and which one having the low cost, that will be coming to the visited list. This process continues until we reaches the goal node. So this procedure will be followed to solve the problem with the help of uniform cost search method. So in this, the familiar words we are using here, priority queue and path cost. So what is priority queue? UCS, Uniform Cost Search, uses a priority queue to stores nodes and always selects the node with the lowest total cost for exploration. Always the cost will be minimum, that shows the best path. So we have to choose lowest cost. That is the very important thing. That lowest cost also total cumulative cost from the start node or root node. So what is path cost? Calculates the cumulative cost from the start node to the current node and prioritize nodes with lower cost. So we give the priority to the node which is having the lowest cost. That is very important. That node point the cumulative cost calculated from the initial node or root node. Consider some problem to solve uniform cost search method. So with the solving this problem, you can get the better idea how to apply this uniform cost search algorithm and find the solution, find the path. So consider this problem. So in this problem, tree structure, we have how many nodes are available? A, B, C, D, E, F, G and H. So now I will consider A is the root node and F is the goal node. This is given in the problem itself. From the A to F, apply the uniform cost search, find the path. How to find the path with the help of uniform cost search algorithm? First, initially the path cost for the root node always it should be 0. It is in the initial state, the cost for the initial node or root node value will be 0. So that is the value I am considering here A naught. Okay, this A naught, this value indicates the path cost. Always this suffix value denotes the cumulative cost for the particular node. So you remember this point, not from one node to another node. It is the cumulative cost from the root node. So this point, if you are remembering, no mistake will happen while solving the problem. The path cost is the not a simply one node to another node. So we have to consider each and every node, traversing each and every node, cumulative cost value will be considered. So now A naught will be taken and A naught will be explored and this successor of A will be B and C. So B value will be 1. Okay. Initial node to B, the cost value, path cost value is equal to 1. So then it will be represented as B1. A naught to C, the path cost value is 2. That will be represented as C2. So now comparing these two values, so we are keeping all the values in the priority queue. Okay, we are considering, we are taking the value from the start node and we are expanding that node if it is not a goal node and we are keeping the value in the priority queue. So based upon the priority queue, we are giving the priority for the lowest path cost node first. That is the concept followed for the uniform cost search method. So B value is 1, C value is 2. Path cost value is 2. So I am taking this way also, you can easily understand. B, the corresponding value is 1. C, the corresponding value is 2. So now we are explored this A naught value. So this is the priority queue and this is the visited list. So now A is visited and explored and we can keep the A value, A node will be in the visited list. Then explore that B and C. So B the corresponding value is 1, C the corresponding value is 2. So now we are seeing these two values. So 1 and 2. Which one is the lowest value? B has the lowest value. So then take that B value to the visited list. So now this B, we can cross the B and then we can move the B to the visited list. So now what is the after moving the node to the visited list? The immediate step, we can expand that particular node. So B node can be expanded. So B successor will be D and E. So then we can keep that value in the priority queue. So already we have C value which is having the path cost value 2, and now we are keeping the expanded B node. We can have the D and E. D the corresponding path cost value. Now you can see it is very important. So here B to D the value is 3, but we are not going to take this only this path cost value, always at the particular node. Okay, so we are reaching this D value means cumulative cost will be considered. Cumulative cost means from the root node to the particular node. So from A to B the path cost value is 1 and B to D the path cost value is 3. So 1 plus 3 the value will be 4. So that's why D value will be 4. Okay, if you are taking the D value as 3 means you can have that not able to solve the problem. The mistakes going to happen. So this part is very important. So A to B 1, B to D 3. So now the D value 4 and similarly what is the E value? Okay, that B node, when we are keeping the B node to the visited list, so then B can be expanded. So based upon the expansion, so we are keeping the D and E in the priority queue with the cost. That cost is cumulative cost from the root node to particular node. So D the value is 4, E the value is 2. So now from comparing these values, okay, so we are having C2, D4, E2. Both the values are same value only based upon placing the nodes. Which one we are placing first? C node will be placed first in the priority queue. Then this C can be moved to visited list. After moving the node to the visited list, that particular node can be expanded. The C connected with F and G. So F and G will be keep it in the priority queue. So this F value means we have to consider the cost, cumulative cost from the root node to F. 2 plus 1, 3. So F value is 3. And then A to C, C to G, the total cost is 6. G value is 6. So then we are comparing all the values. Okay. So we remove that C value. So then 4, 2, this 3, 6. So then E contains the low value, low cumulative cost value. So then we can remove this E from the priority queue and keep it in the visited list. After keeping the node in the visited list, so then we can expand the particular node. E node is the leaf node. So further the expanding is not possible. Then terminate that particular node. So then remaining values we can compare. So D4 and then F3, G6. Comparing these three values, F have low value, lowest value. So then remove F from the priority queue and keep it in the visited list. So now this is the goal node. Okay. So this is the goal node with a cost of 3. So total cumulative cost of 3, we can reach the goal node. Okay. So this is the way we can calculate the total cumulative cost for the goal node and that path will provide the better solution. So this is one of the uninformed search. So this based upon this one, what is the path? Total cost is 3. So A to C, C to F. The path for this particular problem, what is the path? A to C 2, C to F 1. So 2 plus 1, 3. So this is the path for this particular problem. So similar problem we can see another two more problems. You can get the better idea. So consider this diagram. This diagram is the tree structure. Again we have the tree structure. So from this structure we can find out what is the path. So here similar way, first initial node G we can keep it. That initial node always the value will be 0. So then G0 will be moved to your visited list and expand that G value. So after expanding G value we can have H, I, J and the corresponding value H2, I5 and J3. So comparing these three values, which one is the lowest cumulative cost value? H2, and H2 move the H2 visited list and expand the H. H after expanding H, the K value will be keep it in the priority queue. The K value is K6, I5 and J3. Comparing all the values, which one is the lowest cost? J3 is the lowest cost and we can move that J into the visited list and expanding J. So J connected with M and M will be coming into the priority queue. So then comparing all the values, so based upon the comparison, so which node will be coming into the first level we can find out. So when based upon the priority queue, so I will be coming first. Okay, so I5 will be coming into the first in the priority queue. So then I will be keep it in the visited list and expanding I. So I connected with L and the cumulative cost is 8. So L8, M5 and K6 and comparing all the values, this M contains the lowest value. So then move this M to the visited list and expand M. So after expanding M, we can keep the N value in the priority queue with the cumulative cost of 3 plus 2 plus 1. So totally it should be 6. So now comparing these two values, N having the lowest value and take this N to the priority list. So then this is the goal node. Okay, we reaches the goal node condition. So then this path with the cost of 6. So then based upon this cost value, so what is the best path from the starting point to goal node will be A to J, J to M, M to N with the cost of 6. So this is the solution for this problem. Another one more problem. For this, consider this problem. So we have the nodes P, Q, R, S, T, U, V. Here V is the goal node. Okay, V is the goal node. So how to reach the goal node with minimum cumulative cost? Aim is with the help of UCS uniform cost search, we can use the minimum cost to reach the take the path from the initial node to goal node. So similarly, P naught first initial node P naught. So P naught will be coming to the visited list. P will be coming to the visited list and it will be expanded Q3 R2 S7 comparing the value which one is the lowest value R2, then R2 expanded. After expanding R2 Q3 S7 V22. How we are getting the V22 R2 after expanding R2 we are having that R value R connected with V with the cumulative cost of 20 plus 2 22. So Q3 S7 V22. So comparing all the values based upon the position when we are placing the particular node into the priority queue. So 3 is the lowest value and move the queue to the visited list and expand the queue, and expanding after expanding queue, the successor of queue TUV. So T value cumulative cost is 3 plus 3 6, and U cumulative cost is 3 plus 8 11, and V cumulative cost is 3 plus 15 18. So all the values we can keep it in the priority queue. So from this, which one having the lowest cost? T6. Here S7, V22, T6, U11, V18, T6. This is the lowest value, and move this T to the visited list and expand T. So expanding T, this is the leaf node, no further nodes, and terminate it. Okay. So then next we can compare the remaining values. Which one has the lowest value? 7, 22, 11, 18. So S7 shifted to visited list and then expand S. So after expanding S, S to V. So consider here the cost to the V through S will be 7 plus 6, 13. So now V22, U11, V18, V13. So consider here in the same goal node itself with different cost will be available. Different cumulative cost will be available. One value is 22, another value is 18, and another value is 13. So now comparing all the values, which one has the lowest cumulative cost value? That is U11. So U shifted to visited list and then that will be expanded, but here U is the leaf node. There is no further node for expanding U, and this is the leaf node. Terminate that particular node. So then what are all the remaining values? V22, V18, V13. These values available in the priority queue. So priority queue give the preference or priority for the lowest cost node. Here V13. So V13 move to visited list with the cost of 13. This V is the goal node. Okay. So main aim of this uniform cost search, the we can take the path with lowest cumulative cost from the start node to goal node. So here the path will be PSV. So P2S7, S2V 6. So the total cost of 13, 13V 13. So how many moves will be there? How many moves? 1, 2, 3, 4, 5, 6, 7, including with the goal node. So total number of that path we are taken here totally 7. So this is the uniform cost search algorithm. Thank you.